for integration of robotics with geospatial technology and how we build smart city applications with the integration of these two technologies. So that is the purpose of today's talk. I'll move to the next slide. Okay. Now, see, first of all, I will give you the brief of next 30-35 slides. Am I audible? Am I?
Yes, sir.
Can you?
Yes, sir. Yes,
Okay.
you are audible. I'll keep saying yes in between.
Yes, yes. Now I will not. So now the first thing is that the sensors, robotics actually keeping the sensor, and it is movable also. That's the difference between only sensors and robotics. And then the camera, machine learning is basically to record whatever is the existing and then take a better decision. That's use of machine learning in this. Encryption. Encryption is required for the security and the safety of the data. And then the cloud computing. Cloud computing means it's a real time and for 24 hours it's available. And then you have the software and the hardware and the convergence of these technologies, the integration of these technologies together, we call it a application for smart city system. Will make a smart city. And then the output of these integration, what will be the output of these three integration? The output will be same automatic. Few decisions will be automatically. For example, if we are talking about the signal lights, at any point of time through the system, we can change the signal. We can change red it green, green it yellow, whatever. So that means the integration enable us to take automatic decisions. And then there are semi-automatic means we can inform a person so that he can take the appropriate decision. And third thing which it will give is the decision support system, which enable us to implement or to plan a new application, to plan a new things. So once we have the previous data, then we can make a decision based on the appropriate inputs that we get it. Now we will start now.
Yes,
Now,
sir. Yes, sir. Keep going on.
yes, topic covered will be sensors, GIS, geospatial applications, smart cities. These are the three objects: sensor, GIS, and smart cities. What is happening in smart cities? Now, the fourth thing is the integration of these three things. You understood? The three are the objects, and the fourth the topic which we are covering will be the integration of these three things. And then we will have few examples that how the sensors give the input to the system, and then the system works accordingly. And then we will give some idea about the future integration. So the things which are not happening at present, probably it will happen in the future. And the seventh thing will be the conclusion of these things. Now we'll talk about the sensors. What are the sensors which are required, or what sensors are actually? The sensor is an electronic circuit which evaluate and attribute and give this. So in layman language, we can say that sensors are basically input to the system. It acquire information, for example, temperature, for example, light, for example, any temperature, environmental parameters, or anything. There are specific temperature, specific sensors for specific things. So there are many sensors which give you the percentage of carbon dioxide in the air. So you know that or the oxygen, that oxygen is going to finish it, or there's less oxygen in the atmosphere. It's a more polluted environment and the other things. So, and similarly, in fact, these gas sensors, there may be smoke, there may be any number of things. So that means there is a sensor for each specific thing. There are sensors which give you the input that there is a garbage, the bin is filled. So the sensor will give you the idea that how much weight, how much height, and which quality of garbage is there, so that the person who is taking care of the garbage can take decision accordingly. So there are lots of sensors. In fact, we'll talk about. Sensors can be a device, a small equipment like a thermometer, the remote sensing thermometer. That's a device. That's a sensor evaluating the temperature. It can be a module or it can be a subsystem. So these are the three shapes. Sensor can be a naked sensor, a small circuit which gives you the smoke detections or those kind of things, or maybe a full-fledged system, right? And how it works. Now, the working of the sensor, what sensor actually do internally, because it's an electronic circuit. So how it works? They detect event. Now, the first point is detect event changes in its environment. So whatever is a surrounding of the particular sensor, it detects that thing and transmit that through Wi-Fi or through any network, transmit that to the central system. So that's how a sensor works, right? Second thing is respond, send information to the electronics. So, for example, if it senses something and gives input to another electronic system which evaluates it, what it is. So one thing is it directly senses some change, some events in the environment and send back to the server, or it can send to the another electronic thing to work, to do something. For example, there is a sensor on the traffic, on the red light, on the what you call it, yeah, red light signal. And if the traffic is coming from one direction is a more, then it gives the input to another electronic circuit which changes that light to green so that the traffic may pass. So that means the sensor work in a two way. One is directly give input to the server, or it gives the input to another electronic device which take action. Clear? Now,
Yes, yes,
uh, yes. So now the working is this example actually the touch sensor where we have seen the touch sensor. Anybody has a guess? When we press the button of a lift, that's a touch sensor. As soon as you touches that, it gives you the floor one, floor two, floor three. That button is a touch sensor. Whenever you touch a button in the lift, the motion sensor. When there is a motion, in not in India, in fact, in most of the other European country, there's a motion sensor at night. So they sleep. In fact, if somebody moves, some thief comes or anything moves, then it put the alarm that there is somebody which is moving. So that means the motion sensor. Any moving object is there, it senses that and gives the input to another electronic device or the server. And dawn to dusk light sensor. So when there is a light, automatically the street light should go off. So that is called. It's available in electronic shop also, in electrical shop also. Even in India, it's called dawn to dusk. So whenever there is a dark, that bulb or that light switch on automatically. So the bin level, similarly, there is a sensor, bin level sensor. So it gives for example, there's a bin and the height is already fixed, the volume is already fixed for the bin. So whatever, how much bin is filled, it gives the input to the server, so that the worker, in fact, the person who is responsible to clear the bin, he gets the information, and this we will take as example also. Now, another sensor or set of sensor or a board is called the IoT. There are a lot of definitions actually of IoT. This definition is the simplest of them. You will not find this definition anywhere. I wrote it for you to make it simple. Otherwise, Internet of Things, it's very difficult statement actually. Internet of Things. What is thing? What is Internet? What is Internet of Things? So it's basically a circuit. In fact, in this definition, when we add sensors to something. What is something? Something means a object or a vehicle or a machine or infrastructure or anything. For example, a fridge. I'm taking a small example of fridge. In fridge, we are putting a small sensor, IP, there's a small board, small electronics. And then that communicates to me through a Bluetooth. So from here, or for example, we are putting it on an AC, air condition. So when I'm coming to home, I know my AC is off. No, before I go in my room, I want to switch on my AC. But how I can switch it on? I cannot, because I put a small ID, small circuit in my air condition, and that is having a IP, Internet Protocol, that is having an address. For example, 172.203.203.1. For example, so through that the address, through that the IP address, I can switch it on. I can send the signal so that my air conditioner is on. That is what it is called, the Internet of Things. Things means any machine or anything which we wanted to make it off, or which we want to reduce the speed, or whatever we want to do it. We put a small circuit over there which is controllable by a network. My network could be my mobile phone, network could be my laptop, network could be any complex server also. So I'll read it out. When we add sensors to something, we grant that thing. उस चीज को मैं I speak in हिंदी also. उस चीज को हम authorize कर रहे हैं to communicate. So whenever we are adding sensors to something, we are allowing that thing to communicate through the network. That is what the IoT. I hope IoT is clear.
Yes, yes,
IoT
you
is
are clear,
used,
sir. You are clear.
yes, IoT is used in many other applications. There are many other applications. Now, there's small 2 or 3 more slides on IoT. Application of sensor giving our word a digital nervous. So what scientists or what the smart city experts they are calling that IoT is a nervous system of a smart city. Actually, it's a nervous system of a collection of network, right? So so how we communicate in a small city, the very first thing is we want information regarding each and everything in the smart city. Even a small sewer door, if the sewer door is open, sewer door is closed, or anything. So we want to control everything. That can only be done if we put a small sensor on each and everything which we want to control. And that is the nervous system. That is the backbone of a smart city. Stronger the nervous system, better is the implementation, better is to control each and everything in the smart city. Now, I'll read it out. I explained to you. I read it out. I won't actually, even if it takes little more time, it should not matter to you, but you should understand it. Write
Yes,
it
sir.
down,
Yes, sir. Continue.
whichever slide or whichever things is not clear, you write it down so that you can ask me the question on that at the end of it. Now, wait. Yeah. So, so the analysis and visibility of status and behavior, like control, process, and resources. These are the 3 attributes actually to the nervous system. And hence the sensor enabled device. So what is the use of IoT sensors? That enable the device to come into the network, to participate in the network. Hence we call it a nervous system. everywhere senses, the sensors make the object enable them to communicate with the system. That's why we are calling it a nervous system. Now, it's a small example that our all cellular phone, our mobile phone, each mobile phone is having 8 or 11 sensors. Every smartphone is having that much of sensors. कौन सी हैं? I will read it out. Acceleration and tilt sensor. When you tilt a mobile, your landscape to portrait and portrait to landscape, that get changed. So that is how it is thing. Say acceleration or tilt sensor is there. Thermometer, it gives the temperature. So there is a thermometer sensor is there. Humidity and moisture sensor is there. GPS, global positioning system is there. And you can read, there's a leak level sensor is there. Force, load sensor, torque sensor is there. Acoustic sensors is there, which we control your voice and other things. So these are the 8 or 11 sensors. I mean, not every phone is having 8 or 11. There may be 12, there may be 7 different sensors. So these are the sensors which are already available in our mobile phone. And many people probably may not be knowing it. Maximum people knows about GPS. People knows about the motion sensor because if you put an app, it will give you the speed of the vehicle and speed of the moving and other. So that is because of the sensor which. Now, it's a GeoS means geospatial science. Geospatial science application. Now, we have spoken about the sensors. Now we'll speak or understand about the GIS or GIS, and then we will talk about the smart cities and its problem. When we discuss all these three things, then we will discuss about the integration of the, right? So we'll go to the next slide. What is geospatial technology? The geospatial technology, I think you everybody will be knowing it because I think Dr. Talbir must have cleared it. GIS and QGIS, you must have studied. It's a small thing, and the GIS is different between the normal application and the GIS is only small because every in this GIS, all the even all the entities, they go two types of information. One is the locational information, other is the attribute information. That's the difference between the normal application, the normal thing, and the GIS technology. That in GIS technology, each entity is having the locational data as well as the attribute data, which explains about the location. Simple. So the definition of GIS, I think everybody may be knowing it. So it's a system where we are capturing data, we are storing data, we are updating, we are manipulating, we are analyzing, and displaying the data. So the normal definition of GIS. So I will not spend too much of time on this. The integration of there basically in GIS, in geospatial technology, there are 5 components. The people who are working on GIS, very important. Data, those are very important thing. And the software on which we work, the hardware, using hardware we operate the software. And then the analysis part, that's what the GIS analysis. So these are the 5 basic components of a GIS, and I will not spend too much of time. Now, some of the application, again, I will just read it out. I need to explain each and everything. The slope and aspects, the part of geospatial analysis, data analysis, topological modeling, geometric network, hydrology, route finding, and all sort of applications, a lot of applications. But we will be using some of the application in smart cities using the sensor input. So that's why this slide is here. Now we'll talk about the smart cities. What are their problems? What we are going to resolve it, and how we are going to resolve it with the integration of sensors and IoT. That we will discuss. Now, existing situation. What is the existing situation in smart city? The decades of, because we are living in a, mostly living in an unplanned urbanization. When urbanization started actually, so it was not planned actually. It was basically a village, then village converted into a town, and a town converted into a city because of the services and whatever they were requiring in a haphazard manner, in a mostly unplanned manner. We gave transportation facilities, sanitation facilities, and other sort of things to make it a city. In some part of the cities are planned. They, the Delhi Development Authority and other bodies, they planned it. But overall city, overall metro, if you see, even if you see a metro, it is not highly planned. It is not planned as per the problems and other. That's the reason, in fact, we mostly face whenever there is a flood, we face problem. Whenever there is a traffic problem that we face, slum is everywhere, it's a problem. So many other things, in fact. We'll read it out and then we'll say how many of these problems we can address using sensors and other when we are making it smart. Transportation problem is a major problem and it is in every city, almost every city, except probably the Chandigarh or the Gandhinagar. So they are the two planned, but still in, even in Chandigarh also, because of the surrounding and other things, there are a lot of problems. However, it was planned city, it was planned first and then habitated. So it should not be because of the surrounding local towns and other things. Still, they are having problems. So transportation is one problem. Sanitation is always and everywhere. In one of the city of Punjab, like Bathinda, the the main pumps are at a very lower level of altitude. That means the water comes from the higher level to lower level and it fills the entire circuit house. The main wash area is laid in a very low lying area. When we did this survey, we came to know that this was totally unplanned. Now, unless they deeper the sewer more than the altitude of the circuit house and other things, the problem will remain everywhere. And slums is a main problem of every metro and other things. Inadequate housing, corruption, rampant pollution is another problem. In fact, rise. So, for example, taking a small example, the pollution. So there are a lot of sensors which tells that Ajadpur Choraha or Ajadpur signal, the most polluted city or polluted place actually or location or Punjabi or whatever is. So once we have the parameter that it is a 310 level or 500, it should be 100, 200. So we can, if it is a smart city, we can stop vehicle at some Kisbe camp or some other. I'm taking example actually, or some bypass, canal bypass, or some location, and reroute the vehicle so that the pollution goes down, or it should be less than 200 or 300. And just example actually, if we have the input through the sensors, we can take action so that problem or whatever is happening over here should be controlled. So together with vulnerability and extreme weather, so sometimes these parameters are due to weather and other things like malaria and other things. So if we have sensors and control everywhere, we can plan the thing a little better. Next. What basically smart city is actually. Actually, to me, smart city is a normal city should be called a smart city because in a normal city also we need to give a water, we need to give clean water, we need to give clean air, we need to give good transportation system. So that is, but since in our normal city these things are not here in an efficient way, that is the reason we call it a smart city. Otherwise, whatever facilities and other things should be there in the smart city, should be there in the normal city. We are calling it a smart city because of the reason that our normal cities are not having these things in an efficient. We are having water, we are having sanitary system, we are having good environment of the sort of, but they are not planned. Second, they are not in an efficient way of dealing. For example, in most of the places, in fact, the water spill over, the pipe is rusted and other things. So the clean water, the main water actually, which people should drink and other things, go waste. But if we have a smart city, we are working the same situation in a smart city. There is everywhere there is a sensor. If any wastage or anything happens, the corporation, municipal corporation, or the center place or the command center of the GIS or smart city would be knowing that these things are happening at that, then they can immediately repair to do this. So smart city is basically a good information nervous system so that we can plan the things. Oh, smart city definition actually, smart city is based on knowledge and innovation. So everywhere, whenever there's a problem, there's a innovation or the knowledge you have, plan it. For example, when we visited long back, actually around 15, 20 years back, when we visited the slum department of Delhi, so they say, give us some innovative ideas. We wanted to remove the slums and other problems. So we gave them the idea that you measure the distance, measure number of trees, number of slum wells, how many are there. For example, it's say 100 jupis are there at a place. And we can make, at the same place, we can make a building, high-rise building, having 200 houses. So each house of each Juggi will get a free of cost house, and another 100 houses which we sell in the open market outside will we will get the cost of building of that building, cost of building of that building. We can get it by selling the 100 flats. So it is a free to the government, free to the Juggi one, and there is no money involved. So we can make it a such a way that whatever our expenses and expenditures we have incurred on that, we get it by selling those plots and others. So this is innovation. So this can only happen in a smart city or in a planned way. Otherwise, everywhere there will be juggies, and they will be asking, build a building on that and give us free of cost. So this cannot be made as a rule actually. I was just explaining that if the city is smart, a city is a control and everything, so we can apply our brain, our innovation, our knowledge, and then give us a better solution, give us a good solution. Function of 24 by 7 in cloud environment. Cloud environment only gives the real time environment. At every point of time, every second, every minute, we are getting the information, the flow information flow is there. So that means there should be 24-hour light also because the cloud or the servers and other things they work on power. Power. So if you say 24 by 7 cloud environment, it's inbuilt that 24-hour internet should be there, 24-hour power should be there. So that's how the things are integrated for best citizen services and for citizen. For example, citizen, if we classify citizen into 4 or 5 major categories. The senior citizen, they have the different types of requirements. The ladies, they have the different set of requirements. Gents, the working people, or the businessmen, or the children, or students, knowledgeable. So they are different requirement actually. So we need to gather the information and address them according to their need. That's why the first slide we have written machine learning, artificial intelligence. Because they will decide that what is the most appropriate thing for a particular person based on their sex, their male, female, based on their income, based on their age, based on their health, based on many other factors. So we Smart city is a place where each and every information is there and there's good communication of the information. Sustainable practices. Whatever practices that we do, that has to be sustainable. For example, if the wire is cut, or in now, in fact, in city, in Delhi, in place of my house, in fact, if the wire is cut or something is broken, the mechanic comes and he fixes up that wire and then go back. So he never changed that wire. And what is vulnerability? That in next rainy season or next storm, that joint may disconnect again, may give the problem again. But in smart city, we have the information that when the wire was repaired last, if the wire was repaired 5 times or 6 times in a month or 6 times in 2 months, then better is to replace it. So these types of informations are not there in the existing city, which should be there, and that's the reason of we need the smart cities or the cities which is having good communication among things, among objects, among whatever is there in that. This is a just for some knowledge actually. Uh, Emphasizing that the GIS is a central place. It is in the middle of the application. The smart city application or the command center, or you call it a call center sort of thing for a basic thing where whole city is controlled, right? Command center. The GIS application is there on that, and then all other applications surround that, and it's a plug and play sort of system. I'll explain. So in the core of the application, smart city application, there's a GIS center, right? And that GIS center is getting input from a transport department. There is a smart city transport department, which control the transport, which do everything related to the transport, and feed the information back to the GIS application. So transport system is a subsystem. Transport system is a subsystem in an entire GIS application, which feed information to the core GIS platform. Now, the another could be the municipal corporation. Municipal corporation also a subsystem which is having further subsystem. For example, in municipal corporation, there may be a housing department, there may be sanitation department, there may be water supply department, there may be another sub. So each department is a subsystem cater to one specific thing. A water department only deals with the input of the water, cleaning of the water, and storage of the water, and distribution of the water. Of course, they will do it through the sensors and robots and sensors. So, but that system, that subsystem of entire system feeds the information back to the GIS. And that water department system is again having small subsystems. So this is a network of system where the core, where the base core is a GIS. Many scientists, many experts, they don't believe in this kind of thing, but since we are from the geospatial technology, we can design a system where the core or the main platform is a GIS platform, and then there is a subsystems in each and every department. That subsystem may have the another subsystems, and that's how the information or the neuron or the nervous system of smart city works. I hope the things are getting clear. Now, the another smart city GIS, what this application is, little more in detail. It collects information, like I just spoke it, that is the center of the application, there is a GIS, and that collects the information from other subsystems. And the subsystem collects the information from other subsystems. So the one thing is a collect information, right? Second is a manage, and it means to store that information in classified manner, in a classified way, and then compile it. Whatever is not required, they can delete that, and whatever is required, or the multiplication of the system and then generate another system. So, for example, we get the health data and we know the geographic data. So, putting health data on the topology, on the topographic map, we overlay it, and then we can find out which are the location which are corona positive, which are the location which are red zone. How we identify the red zone, green zone, orange zone, and other zones? How? The number of cases they display on a map, and then the area surround that, they make it a red zone or whatever colonies or whatever locations which are coming under the number of cases, corona cases. And then it depends on the density of the, for example, 5 corona cases per unit per kilometer is a red zone. And 3 corona cases per kilometer in a location is a green zone. For example, I'm taking example. I don't know exact criteria. What is the density of the corona zone in red zone? What is the density of the corona positive in green zone and orange zone? I don't. I think this is a public information, may be available in some of the websites. You can find it. But I'm telling you the way how we make red zone, green zone, and other sort. Visualize spatial, which I gave example in fact, that how the temperature or what is the different location or different colonies having different parameters of an environment, which is the best environment like Dholaku and other places may have the lowest pollution and other so. So we can identify this only when we visualize spatio-temporal information. Whatever we have collected, if we overlay these things, we can get this kind of. And who are the stakeholders? Who are the stakeholder in smart city? Because whenever we are developing application, when we are doing something, we need to know that for whom we are doing it, right? So we are doing it for the government is one stakeholder in the smart city. The private players, the private player is a businessman or the shopkeepers and people who are doing commercial activities. That's a private player and community as a citizen, normal citizen, housewives and people, senior citizens, students, and other things. So they are the broadly 3 stakeholders in the smart city. Broadly, there are 3 stakeholders here. Now, now we know now. I'll again be summarized in 1 minute. We know what are the sensors, what they do, how it works. We know what is the GIS, geospatial technology. We know what are the problems of the smart city stakeholders and how it is working. We know all 3 objects initially we discussed. Now we will be giving emphasis how we are integrating these 3 things to get the smart city application. How we are integrating sensor with the GIS application and to give a efficient application for smart city. So this is now, this is what we can explain. This is probably the last part of the presentation. Now, the left-hand side, you see the robot sensor for GPS. GPS is also sensor. So there are sensors on the first place that collects the data. The sensor collects the data and input it to the system, to the hardware and the application, which is together it's called geospatial application. To the geospatial application. And what is the arrow? The arrow is indicating the network. The arrow is indicating the communication way, the way of communication. It could be Wi-Fi, it could be LAN wire, it could be mix of these 3, it could be anything, or mix of all these technology. So it's a communication system. So here it's a communication system. So we have a sensor. Through the communication system, it gives the input to the geospatial application. And based on these things, the software interprets and gives us the DSS, decision support system, and various analysis and display it on the screen. So this is one slide which is indicating the integration, right? So we discussed each and every component. This is one slide which is the sensor takes input to the communication system, this gives in the application, the software in that do the analysis and gives us the decision on how to take decision, what decision we should take, right? I think if this slide is clear, everything will. Now, we'll talk about the application of robot sensor. This is the general application, not very important because here medical is there, everything is there. But some of these applications we use in smart cities. But this is a general applications of robot. Robots are used in, or sensors are used in agriculture, surveillance, border security, in medical cameras and other sort of things are used in, or X-rays are used in medical, photography, film production. We are using sensors, robots, infrastructure inspection, the strength of the bridge or strength of the uh, metro pillar is checked by sensors actually, and how strong is the pillar, if there any bubble, if there any hollow space in the pillar, or they check with the sensor. Survey and mapping environment. These are the general application, not specific to the some of them, not specific to the smart cities. Now we'll see the application in the smart city, the application of robot sensors in smart cities. The immediate goal of sensor is to collect data and pass it to the cloud management platform. So the basic, as we discussed actually times, the basic purpose of the sensor is to collect the data, give the input to the main system. That's Actuators are the sensors. They are the sensors which take decision also, right? So I gave you the example, in fact, in the first slide, that if we put actuators which takes the input from the sensor, that the traffic is there more from one direction, from the north direction of a signal, traffic is more. Then actuators, they switch on the that light to green. So actuators are also sensors, but they are instruments which take decision also, right? Which control. So basically, the sensor which control the mechanism. Sensors are sensors only, but there are special sensors which is called actuators. They take decision also. They take, for example, if there is a flood, so the water gate or the gate of a canal should stop or should lift it up, whatever is it. So the actuators are the electronic devices which do take action also, right? So there are the difference between the actuators and the sensors. Now you know the thing. The alter the lights, green to red, red to green automatically. Restrict the flow of water to pipe with leakage. If there is a leakage in smart city, if the pipe is leaking, so it will stop the water going in that particular pipe, and it will alter the route of that water so that the leakage, the water wastage should till it gets repaired. I hope the things are clear. This is clear.
Yes, sir. Things are clear.
Very good. Very good. Thank you very much, sir. Application of robots. Now, this is some of the. Now we are approaching to the last part of the presentation. So the application, how we build the application. Now, this slide actually, if you see the air quality on top right hand side, the air quality management platform. So it's a subsystem which control the air, which control the environment. And on left hand side, amount of carbon dioxide, nitrous oxide, and nitrogen dioxide. So there are the three gases on the left hand side. So then there is the sensors just below on the left hand side. below the amount of carbon dioxide or carbon monoxide actually. It's written CO, the carbon monoxide. The carbon dioxide is CO2. So the sensor is there which senses these kind of gases, and they feed the information to the central system. On this green box, where we are getting the information for the traffic management pattern, traffic jam, or this. For example, taking example actually of ITO. The ITO at 4 o'clock, from 4 o'clock to 6 o'clock, when the offices the people leave the offices, the traffic is more from one direction. The traffic is more from Connaught Place side. So the actuator, in fact, if there is an actuator without any, now our traffic man has to see, put off all the lights and stand by and then see the traffic and manage his account. But if we have the actuators, in fact, then we know that from the green light from front place side should be more time, should be on more time as compared to the traffic which is coming from the Children Park side or the ITO side, because people are coming more from Daryaganj side or the North Place side to go to the ITO, Jamna Par or whatever places are there. So this is an example actually which traffic management, that there are certain devices based on the sensors or based on the artificial intelligence, based on the earlier pattern, the actuator take decision and then implement. So these can only happen in smart cities where the data is collected at one place and you know each and everything. For example, in Sunday, there may be red light for a very small time because probably people are not there. Or in the lockdown time, why we are giving red lights and green lights? There's no traffic on the road, or there could be traffic on one red signal on the road. So the actuator, if the actuators are there in a smart city, they can take decision whether it's a Diwali, it's a Holi, people more will come from ITO side because it's a holiday. There will not be any traffic from North Place side. So these decisions can only be done in smart cities when we have the very good nervous system, right? Now, two examples actually. Uh, this example is a SWM, Smart Waste Management. The smart waste management, how we do the smart waste management or the solid waste management using sensors. So this in two slides, you would be knowing each and everything which I wanted to convey to you. You would be knowing in these two. So now on the top left hand side, you see the workers are there. Worker means a person who is responsible to clean the bin, right, or the collected garbage. Is a person, sanitary worker or worker. On the right hand side is a supervisor. Supervisor is a person who checks on worker whether on proper time, at a particular time, the bins are emptied or bins, the garbage is collected efficiently and it's sent to the recycling unit, because some of the garbage will go to the recycling unit. And recycling unit needs the constant feed. So it is the total nervous system which controls the feed. If there is a less um, uh, feed or less input in a factory which is doing recycle, so we may empty the bin even if it is not full. You understood my point? So that means there is one thing which is automatic. Once the bin is full or the garbage is there on a full capacity, normally we clean at that point of time. But if that material, that garbage is an input to a factory which is doing recycling, and there is no input to the factory. For example, if you are making biogas or if you are making something, electricity with the garbage, right? So if the unit will get closed down because there is no input, there is no garbage. So even if the garbage is a half level, we can. So why I am telling all these things is basically smart city is not to provide the only facilities. It is a decision taking thing also. The application is not to give the pure water or air or transport system or this and that. It's a total cycle. It's a total system, right? So there is a supervisor, and if you read it out, that I started from the sensor side. The sensor detects the height of the garbage, the weight of the garbage, the classification of the garbage. Garbage is wet garbage or organic garbage or solid waste or whatever type of the garbage classification. In fact, there are sensors, in fact, which senses the classification of the garbage. There are sensors, believe, and the classification, weight, and height. We know that the capacity of this bin is 10 kg. So once the 10 kg is there, even if it is not filled, you understand? Even if it is not full, it's a capacity of weight is complete. If you put more weight, if you put more garbage, the capacity is there. So it will break down. You understand the point? It is not always that we require the garbage, the bin full information, or other information. So these are the sensors, in fact, which give not only the height, not only the weight of the garbage, but there are many other parameters which we require to take decision. So the sensor takes this input to a microcontroller, Arduino based on any other base, give it to the server. Server gives the information to the worker, and worker take decision whether it is to collect or not collect or should wait for some more time and other thing. But the system gives him the information that this is full as per the height is concerned, this is full as per the weight is concerned, or other. Now, the worker goes on that and clean the garbage and gives the input to the supervisor, right? So this is how the things, we can have the actuators also. If the bin is full, we can instruct the actuator that close the lid. It will automatically close the lid, so that people should not put more garbage in that because it's full. So this is a system. Whatever I was explaining is mentioned actually in next slide. I'll go to the next slide now. The sensor sends signal to the server. That's what I was telling you. And the second step is server send status to client one. Client one is a sanitation worker. A worker who is responsible to collect the garbage, the worker who is responsible to clean the garbage, right? So it gives the signal, it gives the information to that. Now the third is server receive instruction from the client 2. Server gets information from the supervisor. So there is a two-way communication. In step 3, there is a two-way communication. The supervisor gives the information to the server. Server gives instruction to the supervisor that this bin is full, and I have already told the sanitation worker Mahesh, and now supervisor know if Mr. Mahesh is going to address that particular issue. If Mahesh is only if some other thing, if supervisor want to intervene, so he can intervene. He can tell the server that no, instead of Mahesh, the Ashok should go, or whatever reason. I'm taking very silly example, but any good reason could be there. So after cleaning, the sanitation worker sent response to the server. After cleaning the garbage, it sent the information to the server that I've already cleaned. Please tell supervisor that this is already been cleaned and initialize the stage that now the server is empty. So server has to pass that information to the bin sensor that the server is already cleaned. And now it's a level is a 0, height is 0, weight is 0, level is a 0. Then take input again and send it to the server. So this is the total cycle, the integration of sensors with the system to give a real time efficient application 24/7 in a smart city. Understood? We'll take another example that may not be very appropriate, but if you, it will open your eyes that how many other things we can do. This application is not the right example for smart city, but this is application of integration of robots with application, right? So another example could be the transport system. Like for example, there's a parking and the parking capacity. Like we go to the plot place, it is written that how many parking lots are empty and how many the parking lot is full. It is written. How they know? In each location, there is a small sensor. There is an infrared sensor which detects a car or vehicle over there. And then reduce, for example, if there is a 100 vehicle capacity, if one car goes inside, the sensor gives the signal to the system, and now the remaining space is 99. It reduces one. And when that car goes, it goes out of the system, it goes out of the from the out gate, then again one space is added in the system. Again 100 empty spaces. So the checking is done to the input gate and the output gate. How many cars are going inside? How many cars are going outside? So they are checked through a sensor and update the information accordingly. But we will just quickly go through this example also. We'll give you some. So crop estimation we can do if we fly a drone on an agriculture field. So we can check the NDVI. It's a parameter to check the health of the estimation of the crop. And the farm mapping includes plants. We can count the number of plants. You will be surprised to know we can count the number of fruit to the drone. The water content over there, the moisture level and other thing, the fertilizer status or the pesticide. So now standard color camera, infrared camera and thermal camera, with these three cameras, so we can find out the health of the crop and the water content, moisture and other things. So now the canopy size, how much is the total chaya bolte hain, the plant top part, how much area it covers, that's called the canopy of a plant. So leaf area index, how many leaf, how much shadow will be there in that. So we can calculate the leaf index through taking the infrared camera or by combining visual infrared image, by combining it to near infrared and infrared, by combining these two, we can get the NDVI, which is a normalized difference vegetation index, which gives the health of the crop, how healthy is the crop. Now, chlorosis. So in tea plant, there's an example actually. In tea plantation, the the insect, it eats the leaf from the backside, from beneath, from backside, not on the top side of the leaf, from the lower side, from the backside of the leaf, it eats the leaf. And in tea plantation, only leaf is a usable item actually. The tea leaves are made to the leaves of the plant, right? If the leaves are not there or leaves are infected, the whole crop goes infected. So, but if we have a camera, if we fly a drone on that particular area, we would be knowing the chlorophyll value, chlorophyll index, and we estimate that there could be a disease there, there could be a problem there, in that. And then one can go physically and check tea plantation and any other plant. So that means through a drone, we can check the chlorophyll value and take decision. So, and other application which precise very good cameras are there. Number of fruit on each tree we can count. How much the production, the overall production actually. Water, fertilizer, how much water is required, how much fertilizer is required. We can remote sensing image. We can calculate through the image taken by the drone, taken by the normal camera, or taken by the satellite image on a macro level. On a micro level, we can fly drone and pesticide it. So we can save water. The estimation, the research paper shows that we can save 25% of the water, and the production can increase by 10%. See the application of sensors. Future idea, some of the future ideas. This also you cannot find anywhere. So these are my own ideas. And crop estimation using drone. This has already been done using satellite image, but on a macro level, and the wrong is more, the error factor is more. Food Corporation of FAO, Federation, some international organization is here. They do the estimation of crop in India on a macro level, but the wrong the information is more than the right information. Approximately 60% or 70% is correct. 20 to 30% is the wrong calculation of crop estimation. So we need to do it at a local level. We need to do it at micro level. Orchard mapping, including plant counts, etc. The pollution eating robots. There are robots which use the carbon dioxide of the atmosphere, or nitrogen dioxide, or sulfuric acid of the atmosphere, and generate electricity for itself. For itself. So that means they are the robots which are called pollution eating robot. Pollution eating robot means there are robots which use the pollutant of the atmosphere and convert in some other form. So hence reduce the pollutant. These are mine ideas. I sell these ideas. You will not find these ideas in anywhere. Want to note down? So weather mobile fixation. Actually, I gave idea to Department of Science and Technology to fly a balloon, and in balloon they can carry sensors, weather sensors, so that on a block level, the farmer will get the information on the weather much earlier or much accurate as compared to weather department of the country or weather department. Survey bicycle using GPS sensors. There are bicycles or vehicles which you can put the GPS on that, and it automatically stores the GPS point, the latitude, longitude, and altitude after every 1 meter or after 2 meters. And then later on, you can download that data and make a map. So the what do you call it? Jungle visits and those kind of things where the maps and roads are not accessible. One can use GPS to make the map, which can be used by later on in fact. So POI capture. So you can put a camera on your vehicle or camera on top of your head or a cap, which identify a ATM and then give you latitude, longitude of that particular ATM, so that you can publish a map of ATM, which ATM is where. If you are passing by some, so you will get the information that the nearest ATM. So POI is a point of interest. POI is a point of the locational data, which can require for electricity department to have the location of the pole, or a irrigation department to have the location of the well. Many point data which are required by their department to take appropriate action. Transport the transformer location. Criminal vehicle tracking using magnetic. For example, if police has a suspect that this particular person is a drug dealer or drug peddler or doing something wrong, so what they do is They put a magnetic GPS in their car, and that wherever they are going, actually, where they are stopping, the police can identify that which place they are going and how much time they are stopping, and they can estimate, they can put an idea that every day they are going from 5 o'clock to 7 o'clock near a particular university, and they may be a drug dealer, they may be doing something wrong over there. Maybe right also, but they get the information. But they put this kind of GPS on a suspect. This practice I have seen myself in UK, in England, and then I got this idea from there only. Or the people who are taking leave on parole. For example, if a person is of some particular thing on a parole, they can put a bangle, they can put a bracelet which is having a GPS to track that person, right? Location-based pollution sensor. This is already there. Actually, there is a one location-based pollution sensor in Punjabi Bagh. I've seen myself. There is a lot of vehicles, matadors, where the pollution sensors are there, and then Delhi government or the other government, they take input at which signal or which place more pollution is there. Moisture detector. Moisture detectors are very useful when we are doing the kitchen garden farming or other sort of farming. We put this sensor in the soil, and then we know that after how many days we need to give the water on that particular plant, and so we can optimize the water contents in, especially apartments where the water shortage is there. At the same time, we can give more water. The plant may get spoiled, or those kind of things we can have a motion detector. So the conclusion. This is the last slide. The conclusion. What we can conclude from this presentation: the integration of sensors with geoscience, geospatial application, geospatial technology makes it online real-time application. So the sensors gives the input to the communication system, to the nervous system, to the central place, and it looks like it's a real time thing. If the water is leaking at 12 o'clock, so it will give the information that right at 12 o'clock or 12 o'clock, whatever time in fact when the case starts, it gives the information to the application. So it's a real time. There's no gap between the event happening and the information. If the major accident happens, if the major blockage is there on the Dholakua road or other road, so immediately traffic police will get information. So because it's automatic, so it's a real time. There is no gap between the event which is happening and the information which they are getting. The integration of sensors makes geospatial application more smart, and so if we put the actuators, in fact, so sometimes they take information automatically. So it's a smarter application. It's a smart application because of the sensor, because of its 24/7, because of its real time. So that's the conclusion, that we have sensors input, we have the GIS application, we have the smart city problem. If we integrate these three things together, so we can really make a real-time geospatial application which gives us the power to manage a city in an efficient way. Correct? I think probably this is a. Thank you very much for your patience, Nadi. I don't know whether I have properly used the time or.
Thank you, Dr. Jaggi. You are well within the time, and it was a nice presentation. We are just starting generating data by referencing, georeferencing, registration, and this is the ultimate. What you have taught, how to apply the geographical information system in practical life or in the cities. Now, there are three queries or questions you can say. All these three are related with that, whether it is practical or not, or how we can apply it at the city level in India or local level? So you can suggest some examples you must have seen somewhere. Please respond.
See, that is a big problem, in fact. Yeah, that is a big. I'll answer this first.
Yes, sir. Yes.
Yes. Yes. See, the problem in India is that the many expert other than the GIS, they come because there's a lot of money actually in this. A lot of information technology people came in this market, and they are drifting the real problem to IT problem. This is not an IT problem. This is smart city problem is not an IT problem. That's the reason, in fact, I have argument with many of the people also. But leave apart that, the real system will happen, Dr. Saab, when we make a small system. For example, in Delhi, if the core application is not designed first, the whole system is not designed at once. We can still make a efficient transport system. We can still make a efficient transport system and then work it. We can still make a sanitation department system and work it. And later on, we can join these subsystems to make a real smart city application. Your question is very right, very burning question, that it is very difficult a city which is already existing to change the things overnight. It is not possible. So my personal view in this is that we should make small subsystems and then implement those sewerage management, transportation, electricity, water department, and a lot of the subsystem we should make. And then we develop a core system and plug in all these subsystems in that to make a smart city real-time application. So unless, or second way is that we have another area where nothing is there. We are building a city from the scratch. We can make city. So the only way of existing city to make a smart city is to make subsystems first, and then later on integrate it with the core system. Next question.
Jaggi sir, there is another small question. At what level it can be applicable, at district or town level? Please respond.
Sir, the cities are normally governed by municipal corporation. So it has to be done by the municipal, because the major part, the electricity, the sewerage, the water, the solid waste, the major part are with the municipal corporation. So the unit can be the entire city. It cannot be lower than that, unless, for example, in Delhi there are three municipal corporations. I think there are three. So one municipal corporation level you can start, but it has to be, the unit has to be the administrative unit, the managerial unit. Or if the whole town is managed by one unit, one administrative or management unit, so it has to be started in the entire town. And if the city is managed by three or four municipal corporations, then it can be implemented on the municipal corporation wise. So that means the unit is not geographic. The unit is the administrative and the managerial department. Yes,
Yes.
sir.
Let us wait. Is there any other question by the participants?
That was the third question.
There is one question regarding the disaster. We will not take this question because it is
Okay.
not relevant. We will take in some other session.
Okay.
Multiple jurisdictions, how will affect it? Multiple jurisdictions are there, sir?
Yes. 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 This problem can only be resolved by these kind of systems. So your question is very valid question, because in our kind of environment, I'm taking example, the Ashok Vihar, the entire Ashok Vihar is managed by one telephone department, but half of the Ashok Vihar is managed by one electricity department and half another electricity supplier, and another half is managed by one, I'm giving a vague example, one water department and another water department. Normally it doesn't happen, but so how it can be managed when the same geographic area is managed by more than one agencies? See, once we have this kind of more than one agency, so geographic area the same, the sensors will the same. Sensor will give the input to both of the application, or if the application is designed, then the authority, the owner of that particular geography, which is managed by more than one department, the authority is with both. The information of that particular area will go to the both the thing. For example, if the sanitation problem is there, that will go to the one department, and if the electricity department problem is there, that will go to the another department, whichever is the owner of that particular utility, whichever is the owner of that particular repair, maintenance, and the administration, the information will go. So it will have a no interference. Though the geographic area is same, managed by different owners, but the only that owner will get that information. So there is a no interference of one person with the another person, even if they are managed by many people. I hope it is clear.
Yes, sir. Yes, sir. Clear. I think now we should wind up the session.
Thank you very much.
We are very thankful, Dr. Jaggi, for a very informative presentation, and I think we will call you once again sometime in a day or two to having a very good interaction. Thanks, Jaggi sir.
Thank you very much. Thanks everybody. Thank you very much. Thank you, Dr. Dalpil. Thank you very much.
Okay, sir. You stop this sharing, sir.
Yes, yes, yes. I will. Hello.
So, dear participants, you must have enjoyed. I think it's better to keep you mute. So, whosoever want to speak, he can unmute his speaker. Hello, everyone.
Yes, sir.
Yes, I'm taking the information setting.